There are homes in this country built in 1887 that will outlast every single new construction going up in your neighborhood right now. Think about that for a second. A house built before electricity was common, before indoor plumbing was standard, before any of the advanced materials your contractor is trying to sell you today even existed. Still standing, still solid, still worth more than the spec home 3 doors down that's already showing rot after 8 years. That's not an accident, and it's not nostalgia. It's material science. The builders who put those homes up in the 1880s and 1890s didn't have engineered composites or fancy siding systems or oriented strandboard sheathing. They had 5 categories of material that nature and time had already tested for centuries. And here's what the modern construction industry doesn't want you sitting around thinking about. Those materials still exist. You can still use them, and they will still outlast everything else on the market by decades. This is the list they don't hand you at the lumberyard. These are the only 5 building materials that genuinely last forever. The reason modern homes fall apart so fast comes down to 3 decisions the industry made, and none of them were made with you in mind. A contractor in western Pennsylvania who's been building and restoring homes for over 30 years told me something that stuck with me. He said the single biggest change he's seen in his career isn't the tools, isn't the codes, isn't even the labor. It's the wood. He said he can tell within 60 seconds of walking into a house whether it was built before or after 1985 just by touching the framing. That's not poetic. That's a structural reality. So let's break down how we got here. 3 drivers, 3 decisions that turned your home from a generational asset into an appliance with an expiration date. First, the engineered wood trap. In the post-war building boom, most residential framing still used solid dimensional lumber, true 2x4s. Old-growth Douglas fir, southern yellow pine, heart pine in the south. Dense, resin-rich, tight-grained wood that took a century to grow and was nearly impervious to moisture and pests when properly sealed. Then old-growth forests ran out, demand outpaced supply, and the industry pivoted to fast-growth plantation timber, trees harvested in 15 to 20 years instead of 80 to 100. The problem? Fast-growth wood is softer, less dense, and far more porous. It absorbs moisture faster, it warps faster. And when the industry needed to make engineered products, oriented strandboard, laminated veneer lumber, laminated strand lumber, they needed binders, adhesives, resins. Those binders are the weak point. When moisture gets in, and in a house, moisture always gets in eventually, those adhesive bonds begin to break down. Repair technicians who work on water-damaged homes report seeing sheathing that looks structurally intact from the outside, but crumbles in their hands after a single moisture intrusion event. This is not a fringe problem. This is standard modern construction. Second, the efficiency standard squeeze. Starting in the early 2000s and accelerating through the 2010s, federal and state energy codes began mandating higher insulation values, tighter building envelopes, and thinner structural assemblies. The intent was energy savings. The outcome, unintended or not, was thinner walls, reduced material mass, and a construction industry sprinting toward whatever hit the efficiency numbers at the lowest cost per square foot. An HVAC specialist in North Carolina described it this way. He said, modern homes are essentially sealed plastic bags. Great at holding air, terrible at managing the moisture that builds up inside that bag over time. When you build tight and you build thin, you eliminate the natural drying capacity that older, thicker-walled homes had built in. Moisture that used to dissipate now sits, and sitting moisture in engineered wood is a slow-motion disaster. The materials got lighter and cheaper at the exact moment the homes got more airtight. That combination is a rot accelerator. Third, the builder incentive problem. Here's the one nobody talks about. A production home builder, the kind putting up 50, 100, 200 houses in a subdivision, gets paid when the house closes. Not when it hits year 10. Not when the siding starts delaminating, not when the roof deck softens. They get paid at closing and they're gone. Home inspector associations have documented a consistent pattern of builders substituting specified materials with cheaper alternatives mid-project. swapping out roofing for lighter gauge product, using thinner window flashing, skipping moisture barriers and cavities that won't get inspected. The incentive to cut corners is baked into the business model. You're not buying a home. In a lot of cases, you're buying a 30-year mortgage on a 25-year building. And that gap, that 5-year gap between your debt and your structure, is where the industry profits. Now let's talk about what's actually being sold at your local home improvement warehouse, because some of it has a track record that should make any builder nervous. Certain engineered wood siding product lines have faced consumer complaints and class action litigation related to moisture infiltration and delamination in high humidity climates. Homeowners in the Pacific Northwest and Gulf Coast regions have reported siding showing signs of failure within 5 to 7 years of installation. Court documents from related proceedings reference claims of delamination, swelling, and paint adhesion failure. And these aren't isolated cases. Consumer forums dedicated to siding failures have accumulated tens of thousands of posts from people dealing with warranty claims denied on technicality or repair costs running into the tens of thousands. Vinyl windows, specifically the sealed insulated glass units in budget and mid-range vinyl frames. The seal between the two panes of glass is doing a job, keeping inert gas in, keeping moisture out. When that seal fails, you get fogging and condensation between the panes. Replacement window contractors report that seal failures in budget vinyl windows are increasingly common in the 7 to 12-year range. The window looks fine, the frame looks fine, but the thermal performance has quietly died, and you're heating the outside. And get this, even some of the more widely recognized names in roofing shingles have faced documented warranty disputes over premature granule loss and cracking in the 15 to 20-year range. Shingles marketed as 30-year and lifetime products showing accelerated weathering within a decade. Roofing contractor associations have flagged this as an industry-wide pattern driven by lighter mat weights and thinner asphalt layers, cost reduction moves made at the manufacturing level. The pattern is always the same. Product launches with an impressive warranty. Fine print defines lifetime as the life of the home's original ownership or voids coverage for installation variations that any normal install would involve. And contractors are left explaining to homeowners why a 30-year shingle needs replacing at year 16. Here's the math that nobody in the showroom will ever do for you. Take a standard 2,000 square foot home exterior. Vinyl siding installed runs approximately $8,000 to $12,000. Expected lifespan before significant maintenance or replacement, 15 to 25 years in most climates. Call it 20 years average. Your cost per year is somewhere between $400 and $600. Now run the same math on full brick veneer. Installed cost, $18,000 to $28,000. Expected lifespan, the life of the structure. Properly installed brick on a properly built foundation does not need replacement. Ever. Amortized over 50 years, and brick will easily last 50 years, your annual cost drops below the vinyl number. Cheaper per year, zero replace. Ment cycles. Zero disposal costs. Zero repainting. Zero warranty battles. The expensive material is often the cheaper material. The industry just needs you not to do that math before you sign the contract. Same calculation on metal roofing versus architectural shingles. Standing seam metal costs 2 to 3 times more installed, but shingles need replacement every 15 to 25 years. Metal lasts 40 to 70 years with minimal maintenance. One metal roof versus 2 or 3 shingle replacements. The metal wins financially, and it wins by a significant margin once you factor in the labor cost of each re-roof. The upfront number is real. The lifetime number tells the true story. So here are the 5 materials that have genuinely stood the test of time. Not marketing time, not warranty time, actual generational time. Number 1. Solid brick and natural stone masonry. This is the oldest building material on this list, and it is not close to being displaced. Fired clay brick has been used in construction for thousands of years. The reason is simple. It does not rot, it does not warp, it does not delaminate, and properly installed, it does not absorb meaningful amounts of moisture. Brick buildings from the 1700s are still standing in this country. That is a performance record no engineered product can touch. The pro tip here is mortar maintenance. The brick itself is nearly indestructible. The mortar joint between bricks will need repointing every 50 to 100 years depending on climate. This is a maintenance item, not a replacement item. Big difference. Best use case: exterior walls, foundation veneer, chimneys. Price range is $15 to $30 per square foot installed for brick veneer, higher for full structural masonry. Number 2. Old growth or reclaimed structural lumber. Douglas fir, heart pine, longleaf pine. I want to be specific here because wood is not a monolith. The wood being framed into houses today is not the same material that framed houses in 1920. Old-growth Douglas fir and heart pine, the kind you find in salvage yards, barn deconstructions, and specialty reclaimed lumber dealers, is dense, resin-saturated, tight-grained, and extraordinarily resistant to moisture and decay compared to modern plantation timber. A restoration carpenter in Vermont who specializes in historic home rehabilitation told me he regularly pulls 100-year-old heart pine floor joists out of homes during renovation, mills them, refinishes them, and reinstalls them. The wood, he says, is harder and more stable than anything he can buy new today. You can't order that from a standard lumberyard, but you can source it. Expect a premium of 30 to 60% over standard dimensional lumber, but for structural applications where longevity matters, it is a different category of material entirely. Number 3. Standing seam metal roofing. 40 to 70-year lifespan. No granule loss. No UV cracking. No algae streaking. Wind resistance that outperforms shingles in high wind testing. Fire resistance that most shingle products can't match. Standing seam is the specific profile that matters here. E-seams between panels interlock and rise above the panel surface, meaning water has no fastener penetrations to infiltrate over time. Compare that to exposed fastener roofing or standard shingles where every nail is a potential moisture entry point. A homeowner who installs standing seam metal roofing today may never re-roof their house again. One and done. Pro tip: specify a Kynar 500 paint finish, which carries a 40-year fade warranty from reputable manufacturers. Number 4. Properly reinforced poured concrete. Concrete gets a bad reputation because bad concrete is everywhere. Concrete with insufficient rebar, insufficient mix strength, insufficient curing time, that concrete cracks and degrades. Properly engineered, properly placed, properly reinforced concrete is a different story entirely. Roman concrete structures have survived 2,000 years in harsh conditions. Modern concrete science, with properly specified compressive strength, rebar reinforcement, and moisture barriers, produces foundations, slabs, and walls that will outlast any wood-framed structure built beside them. Get a soil engineer involved on any foundation project. Specify your mix strength. Don't let a contractor talk you into skipping the rebar to save $400. Number 5. Copper, plumbing, flashing, and gutters. Copper has been used in plumbing applications for over 4,000 years. That track record exists for a reason. Properly installed copper plumbing does not corrode under normal water chemistry conditions and has documented service lives exceeding 50 to 70 years in residential applications. A master plumber in upstate New York told me he's pulled copper supply lines out of homes during renovation that were installed in the 1940s and were still fully serviceable. He's also replaced plastic runs that were installed in the 1990s. The copper outlasted the modern alternatives by decades. Copper flashing and gutters carry the same argument. Copper roof flashing around chimneys and valleys, installed correctly, will outlast the roof surface it's protecting. Contractors who substitute aluminum or plastic flashing to save a few $100s are setting up the homeowner for moisture intrusion within 10 to 15 years. Copper doesn't play that game. The rule is simple, and once you hear it, you won't forget it. Build with what was already standing before you were born. That's it. If the material has a track record measured in decades or centuries, trust it. If the material was invented to solve a cost problem that the manufacturer had, not a performance problem you had, be very skeptical. Here's the short version. Skip engineered composites anywhere moisture exposure is possible. Look for materials with century-long track records in climates similar to yours. Choose solid masonry, reclaimed structural lumber, standing seam metal, properly reinforced concrete, and copper wherever your budget and application allow. The homes that last don't have better technology inside them. They have simpler, proven materials that time already tested before any manufacturer put a logo on them. How old is your current roof? Drop the number in the comments. I'm guessing most of you are closer to a replacement than you think, and you're about to find out what your original installer's material choices actually cost you. If you're building or renovating and you're tired of being handed a list that benefits the supplier more than the structure, subscribe. This is where people come to build once and build right.